All right, welcome back to another week. We've covered a whole host of topics thus far. We've talked about how do you create an environment. We've talked about using height fields. We've talked about how to shade those height fields using displacement. We've talked about scattering assets on those height fields. We've talked about how to make trees and how to create an asset that has level of detail, that has proxies. And now one of the questions that will frequently come up is, what do I do when my displaced geometry no longer lines up with the points that I'm trying to scatter assets onto? And the first thing with that we can look at is, what are the best ways to build an environment? When you get that hero and you're that tight, is it better to get a better sculpt so you're less reliant on heavy displacement for something that's that close that you can see that interaction? Or what's a way that we can solve that if we can't? So I would argue always that it's best to break off that chunk, make a higher resolution so our displacement's kind of baked into our height field, and rely less on large scale displacement and only use small scale displacement to get that realism. But let's pretend that we can't do that. And let's look at, if I have a thing that the client has bought off on, the director's bought off on, how do I take my points and move them to that surface? All right, let's dig in. So we're not going to go into building. I know a lot of times I'll start these tutorials with a quick build to get us to this point, but we've gone through how to construct an environment enough times that if you're curious as to how to do this, you can go back and look at those old tutorials. So let's take a quick look at what we have here. So here's our scene as it is in Solaris, where we have a couple of cameras. We're importing the ground here that we've made using the Houdini terrain system. We are setting its some displacement quality, and then we have some shaders on there. We're referencing an asset, which is this tree here, our fir tree. And then we're doing an instance, and that instance is pointed at some points that are happening out at the object level. So let's go look. Okay. So if we go to the object level, as we finish kind of taking our tour here, we've got a height field. We see that we've got an environment. It's pretty simple, right? We've got a height field, some noise. We've run some simulations, a little slumping. And I think I've output a couple of attributes for shading. Then we convert that height field. And then over here, coming off of the height field before it gets converted to geometry, we are scattering some points, just using the height field scatter, nothing special, just using some density to set those points up. If we take a look, we come into our camera, this is our view of each of those. And now let's jump back over to Solaris. All right, so if we were to take a look at this and we were to go ahead and hit render with the XPU, this should render fairly quick. It's not too terribly heavy. We've got some trees in there. Those might take a second to displace, but they're on low res. And we can see here that our tree is sitting on that geometry. So I'm going to go ahead and just open up my snapshot, tray here, and we're going to hit snap once this kind of finishes. 3-second render, not too terrible. So we can kind of take a look. So if we come into the materials here, I've got a not too terribly complex material. So if we look at this, these are all triplanar projections. They are two different rock materials. One is a rock, one is like a sand. And those are combined together to give me my output for my shader. Excuse me. And then I have my displacement down here. And these are all being driven by some geometry property settings here, which is mask, is splitting between these two materials. So the simplest way to do this process is if you have a simple shader and it's just using UVs, we can actually take our displacement map and we can apply that. So let's take a look if we were to do that. Before we get into this more complex, let's look at if we drop down a Material X node, and we'll jump inside and we'll just do something really simple. We're just going to use a texture. That's an image, right? Just a plain old image. This is going to, by default, pull the texture coordinates, the UVs that are on there. We'll plug this into base color, and we're going to copy this, paste, we'll make it a float, and plug this into displacement. As far as file name, let's just grab something that I've grabbed before. So there I've got my displacement. Let's make sure these are the same. XG. Yeah, okay, great. So let's go ahead and attach this to our surface. And we'll put down, this is going to be material 1, and we'll let that render. All right, so we've got a render. We're going to do a couple of quick things. We're going to go ahead and do a fit range or a remap, I believe it's called. There's always so many ways to call the same thing depending on what software you're in. And so in this case, it's going to come in as 0 to 1 because that's what our texture map is mapped to. But we're going to remap this back out to negative 0.5 to 0.5. That way we have our halfway point is set to 0.5 essentially. So there'll be no displacement where the map is at 0.5, and anything above is going to displace out. Anything below is going to displace in. The other thing that we'll probably do here is we're going to go ahead and we will crank our displacement to see if we get anything a little bit more than what we currently have. So let's just push that to 10, restart the render. All right, so we have our render. Now to illustrate the point, I went ahead and just cranked on the scale and made this a scale of 100, and we can see that our trees here in the back are all floating, right? We don't have a good connection point like we did before. This is on the verge of floating. This one here is floating, floating, floating. This one is intersecting, intersecting. So we'll go ahead and take a snapshot of this so we can have that to go back to. And now let's go through and say, how do we do this same thing on our points? So at this point, it's pretty straightforward. So I'm just going to go ahead and copy this map's path. We're going to jump back out to our object level. Before I do that, I'm going to pin our view here. Actually, we're not going to pin the view. Let's go to our object level. Okay, object. We'll go inside our height field. And right now, here are all of our points. And just for visualization, we'll put down like a merge so we can kind of see our points on our surface. So we'll do something like this. All right, so we can see our points. They're right on the surface. We can do a couple things here. We can do an attribute VOP. And let's pull it off of here, off the normal. And we're going to put down a texture. And we'll just paste that same image in. And then we're going to use a displace along normal node. And for our value here on our texture, we'll make this, it's going to stay RGBA. So we'll do a vector to float just to be clean, right? Just to make sure. We'll take a vector to float. We'll pull off the first color here and put that into a mount. And then for scale, we're going to go ahead and do the same thing. We'll do it at 100. Now you'll see that jumped way up. So one of the things that we need to do is we need to do a fit range node and do that same trick where we're going to take from 0 to 1, negative 0.5 to 0.5. And so here we see that this is doing essentially the same thing we see in our displacement because the UVs are the same at whatever level, regardless of whether we're doing that at shading time or doing that to the actual geometry. We don't have quite the same detail in that displacement, but we have it. So now in reality, we could just take this same thing, right, and paste it to our points. And then let's merge these two now. And take a look, and we can see that our points moved with our surface. Now, sometimes you won't get a perfect transfer. If we look at this, we need to make sure that we have a UV attribute, which in this case we do. So it's pulling the UVs and it's able to displace on that. We probably would want to take and copy normals over just to make sure that the normal direction is the same. So let's do an attribute transfer, and these normals are on the points. We're going to go ahead and put that into the second input, and we'll tell it we just want the normals. And let's see if this changes anything. I don't expect it to change much. Yeah, it doesn't look like it's really changing anything, but for good measure, I'll leave it in there. So at this point, our points are going to match, right? So I'm going to set this our geo. So our geo is going to pull in our non-displaced geometry, but our points are going to pull in these now displaced points. So we can go back to our stage, and we can take a look at what this is going to result with the new scatter. Okay, so if we take a look at this now, we can see all those trees that before were floating now appear to be down on the surface, right? So, and lifted out of the surface. So we'll go ahead and take a snapshot, and then let's just view these two images, and we can jump back and forth, and we can see that now our trees are indeed growing out of our properly displaced geometry. So if you have a simple shader that's just using the UVs, that's not doing any tiling, you can mimic the tiling as well. If you were doing any tiling, you just need to mimic that in the attribute VOP on your points to make sure that the map is applied to those points in the same way that it's applied to your geometry. So that's pretty simple. I'm not going to go any further into explaining that. If we're in here using our material and we brought in a texture coordinate, now that I just said I'm not going to go into any further, and then we did a texture, let's see, do transform. I haven't done this here. I think you would just scale this. But anything that you do to the texture here to make this repeat, we would do the same thing to the points. So that way we get the same lineup. It's very straightforward. It's just kind of a one-to-one match. Where it gets more challenging is when we use a material like this, where this isn't even that complex compared to some of the things we've done so far. But when you start to have triplanar projections, okay, well now we've got to figure out how do we go about matching our triplanar projections to what's happening. So let's take a look at now if we switch this from material 1 back to material. Okay, so when we take a look here, we have really the same problem, right? We can see that these trees are all buried deep down into that where they shouldn't be. This tree is floating a little bit. This tree is floating a little bit. I think we have some floating trees back there. So now we've got to start digging in and how do we go about making this something that is usable. So we're going to take a snapshot so that we can go back and compare. And the first thing that I like to do is try to get an idea of what exactly is my triplanar shader producing. So I'm going to create another Material X Builder node. I'm going to go inside and I'm going to put down a triplanar projection. And for this triplanar projection, I'm going to go and use, if we go here to the Houdini texture and then just go up one directory into the Houdini pick, we can scroll down and there's going to be a UV color node. So we'll use this UV color rat and then we'll plug this into base color, and then we can go ahead and switch this over and we'll do a render. So this is going to be material 2. Okay, and as we see here from our render, like, oh, well, that doesn't look like a color grid. Well, we can see here down really tiny, there's our color grid. So we need to come in, and I'm going to go ahead and put a position node down, and I'm going to put down a multiply. And then what we're doing here is we're essentially going to be changing the size of the geometry before the texture gets applied. That doesn't change it in how it renders, it just changes it in how the texture gets applied to that surface. Oh, part of this is I need to have this in all 3 channels, right? So, but we can still see that that's really tiny. So I'm going to go ahead and take this and I'm going to say 0.001 on all of these. And now we see that we get kind of a nice little lineup. And I've got a second camera here that we can look at that gives me this kind of world view of how the texture looks being assigned through the triplanar projection. Now the interesting thing about this is by multiplying it by 0.001, we're essentially taking this from what would have been a 1 meter or 1 unit square object and blowing it up, which is what this is, right? Which is 1,000, right? So tenths, hundredths, thousandths as far as the size. So it's really mapping an exact UV map scale onto this, so the texture map is going to just stretch one time on this object. So I'm going to come back out to my stage, and I'm going to go ahead and just we're going to get rid of our instances and look at it in this way. Okay, so fair enough. We could quickly take a look and see if we can make this match. So we're going to do this first on our geo, and then we'll transfer that to our points. So I'm going to go back to my my object level. And we're going to come inside here, and I'm going to go ahead and put down an attribute VOP. And we're going to go inside here. We're going to put down a texture just like we did before. Oh, that's right. This is where the challenge is, right? So if we're inside the attribute op, I forgot all about this, is if we type triplanar, right? There's this Quixel mantra triplanar, and I haven't tested this, to be honest with you, right? You know, we could, you know, throw together, you know, we could put on a texture here, right? So we could come here and say, what's our, we're using our UV rat. It's interesting that that's outputting that as a float, right, and not as a color. That's a little strange. Again, I've not used this node, so I'm not totally sure what that is expecting or why. Oh, and it's interesting here. This may not be something that's going to work in VOPs because it's really designed around a shader, it looks like, because it dropped down that principal shader to go with it. So I don't think this is even going to work. So this is why I don't use plugins and other things as much as I can. I like to build it myself. So how do we go about making our own triplanar projection? Essentially is what we need. Because we need to be able to triplanar project our displacement map onto our points. So right now we're looking at it as in reference to our geo so we can better understand this. So what does a triplanar projection do? Well, a triplanar projection is going to project UVs at render time through the X, Y, and Z planes. So let's go ahead and just put down a UV texture node to start us out. And so the default, which is what's on here, is a Y UV plane, right? So we see that from the Y. But what I want to do is I want to do this from the X. And we'll see there's my X UVs. And I also can do this from Z as well. So these will give me UV coordinates from each of those axes. Now, how do I blend these together? Well, if we look at the triplanar node inside of Material X, on this triplanar node, we have this blend method, which controls how those things, you know, are cut out. I don't know, is this the shader I have hooked up? I can't remember. Fascinating that it seems to be doing, oh, I guess when we go to 0, look, we're getting, basically, it's just the Y map, and then this is our kind of our soft, and we get a little bit of everything through here. So you can tell that this really favors that Y direction. If we had more vertical faces and we reduced this, we would get more, you know, Y, but you know, you can see there's some faces that are, we get some sharp difference between those two. But because we've just been dropping this in and using the blend as it is, and that's how that's how my shader is set up, then that's all I have to worry about. So let's go back out to our object level. Let's jump inside our geometry. And now the question becomes, well, how do I get 3 different types of UVs? Well, here's the cool thing about Houdini is just, and you can do this in Maya too, where you can generate multiple maps, UV sets. Houdini, it's just another geometry type. Anything could be a UV, really. You can name it whatever you want. UV is just a default name that everybody has kind of decided they'll use as texture coordinates. You could define your texture coordinates however you want. So in this case, I'm going to go ahead and call it UVX, and I'll make this the x-axis. And just for visual purposes, I'm going to do 3 of them, even though that we really already have the Y. I'm going to go ahead and say UVY, and I'm going to say UVZ. Make that the Z-axis. And so now if I look at this from the scene view, it goes back to being that Y because we still have our default UVs that were coming out of this that I haven't touched in case I've done anything special to make better UVs or more relaxed UVs. This will give me something that is totally separate from that. So how do I view these? Well, I can come to my UV viewport, and right now this is showing me the UVZ vertex, and I can go through all of our different UVs that we've just created and see those there. As far as seeing them in the viewport, right, on this, that's a great question. I would assume this is the show UVs when UVs are present. I don't know if there's a way to kind of tell that which you want to. I've never worried about it or felt I needed to. If I wanted to kind of take a look, I could do an attribute map, right? An attribute from map, and we'll just use our same, oh, not point group, sorry, texture channel, that's not it. Where's our file? Oh, it's right here. It's already plugged into that for me. Thank you very much. UVX, and that was trying to select a point group. And there you can see that this is using UVX for its attributes. That's how it's mapping. And so I can look at my Z, and that's how that's mapping, and look at my Y. Awesome. Okay, but we want to merge all these together. We want a triplanar system. So how do we do that? Well, this is where we plug back into our attribute VOP, and we're going to come inside. And first, before we do that, if we take a look, right now our UVs live on our vertex, but really we want to move these to our points, because when we move to our points, they don't have vertices, they're just points. So we're going to use an attribute promote node. Plug this in. And we can just come in and tell it which attributes from the vertex that we want to change. And so I'm just going to say UV star in this case, and it'll move them all to the points. So now if we look, those are now all here, UVX, UVY, UVZ, where before they were down on another line that's now gone because we have no vertice attributes. Okay, so the other reason we want to do that is because when we come into here, we are operating on the points, and so it's easy to just pull those in. So we're going to use a bind node, and this allows us to pull data off of the surface, off of our geometry, and we're going to say UVX, and I'm just going to copy and paste this, copy, paste, paste, and this is going to be UVY. Oops, that's not UYX, UVY, and the next one's going to be UVZ. So now we've got all three of our UV attributes coming in. How do we go about mixing these? So the main one in this case is going to be the Y. That's the most, but it really doesn't matter the order that we do this. It should give us really the same result. I might be wrong on that, but I know that this works because I've done it before when you have the blend set to just 1. So what we're going to do is we're going to use a fit node. Is that what I want? No. I'm going to use a I'm going to use a fit range node, and what I'm going to pull off here is I'm going to come off of my normals, because that's what the blend is doing. It's based off of the surface direction, and so we're really going to kind of create 3 of these where we're going to pull off the specific normal direction that we want to use. So we're going to use a vector to float. Drop that in the middle there, and this will be our fit X. And then we're going to have a fit Y and a fit Z. Now all of these are really going to be the same amount because our normal is goes from -1 to 1, right? So where it's pointed in the negative axis, it's -1. Where it's pointed in the positive axis, it's +1, and then there's a range based on the angle difference between those. So in any of these, we're just going to say from -1 to 1, remap to 0 to 1. And the reason we do that is because the ramp parameter is looking for a 0 to 1 mapping to do its thing. So we're going to call this spline color, and we'll call this X ramp. And I'm just going to copy and paste it twice. This is going to be our Y ramp. And this is going to be our Z ramp. Okay. Now, if we come up a level here, we're going to see that we have those ramps here now. Great. So what I want to do, went the wrong way, is I want to now start, looking at this and blending these together and seeing what this does. So I'm going to go ahead and use texture map. And just like a triplanar projection, it gives you the ability to plug in 3 different textures. And we are going to do that here because each one of these texture reads is going to get its own UV coordinates that are going to be distinct from the other. So we'll paste all 3 here. I'll clean that up in a second. Move my UVs up. Like that. And so just for naming, we're going to call this texture X. texture Y, and texture Z. And with each of these, we're going to plug our UV coordinates into the UVs of these textures, right? Oh, all these lines need to be set to vectors, not to floats. Even though I believe it will figure it out properly. Okay. And now we're going to go ahead and we're going to say, we're going to use a color mix node for our first one. So we'll do color mix. And we're going to start with our X and our Z. So we're going to take this and put our primary is going to be one of these, and our secondary is the other. And let's go ahead and just plug this in to P. Oh, sorry, not to P. Into CD, which is our color. And oh, that looks fun. That's because this is using the mandrel, right, for both of these pictures. We could take a look at what each of these is resulting in just by going through, and we see there's our X, it's got some stretching in it. Our Y is going to look like our normal texture, right? And then our Z is going to look similar to our X with some stretch. Okay, I'll plug that in. So in this case, I'm going to select all three, and maybe right now I'll start with one to make it a little easier to differentiate. And we're going to go get that color, that UV color again, UV color rack. And so we can see, we know that the mandrel is our Z and the color grid is our X. That'll make it easier for us to see what's happening. Now, just like all of our other process of mixing, there's a bias here. And so we can say, what do we want to drive that with? And in this case, let's go ahead and use the X ramp. And so we can see here's our X direction, and it actually got more of the mandrel really in those in this direction. So let's look at our ramps now that we made, and why did we make them? Well, right now, based on how we did the fit range node, we said from -1 to 1, map that to this ramp. And so our X ramp, -1 is now 0 because of that fit range, which is here, and 1 is here. So at 0, or at -1, it's 0, or giving us the Z map. And when the X is at 1, we're getting the X map, which is the color grid. So we're getting mandrel to color grid. Now, we want it to be the X everywhere that it's pointed, whether it's -1, sorry, it's the other direction, -1 or +1. We want both directions to do the same. So what we're going to do is we're just going to bring this up, and we'll grab the middle and pull that down, and we want this to be 0.5. So now what we've done is we've made a mask that says when I'm pointed in the positive X, when I'm pointing the positive X, give me the X map. And maybe we should do this with color. This will actually be easier test if we start with colors. So we're just going to do a constant, and we're going to tell it to be a color, and we'll make this red. So we'll call this color X. This is going to be Y. And this is going to be Z. Okay, this will be easier to see. So we're going to take this color and plug this in there. Right, there's our X, and then here's our Z. And so there we can see where we're getting, where it's facing in the positive X, we're getting blue, and where it's facing in, positive and negative X, we can see this here, right? So when we look at these mountains, we should see here and here. Now, I'll point out that what we have is not that, right? This direction here, a face facing that way is facing the positive X. A face facing this way is in the negative X. So right now we just have those crossed. So because this is our X ramp, I'm just going to come in here and reverse that. And now we can see we have where our X is facing positive, we get the red, negative, we get the red, and the rest we get as Z. Okay, now you'll notice that all this extra changed, right? And that's okay, because when we add the Y into this equation, it's gonna correct for that. So now we're going to come down here and let's, well, before we do that, let's just change and we'll match this kind of setup. So our Y ramp is going to be the same thing. And we can just right click on this and we can say copy parameter and then right click on the Y ramp and we'll just say paste values. And so now we get the same ramp and we're just going to right click here and say paste values. So I think the reality is I'm overbuilding here. Being that we're doing it this way, we really only need 2 out of the 3 ramps, but we've got them all in here, so that's fine. So I'm going to put down another color mix node, and this one is going to, for its primary, it's going to take this, and for our secondary, we're going to take the Y. And let's plug this into our color now, and there we go. So what we can see here is we were taking, from the wrong thing. We want the Y ramp from where we have, that doesn't look right. So when it doesn't look right, what I do is I just basically come in here and flip this and say, that's the Z ramp. That's why that doesn't help me, the Y ramp. Now the reality is, if we were to go and look at our output from our other, there is contribution here, which when we look at how this rendered in the stage, we could see just tiniest bits in these slopes of our different maps coming through. It was really mostly just a Y projection because so much of this faces up. So let's take a look at what this looks like when we switch from our colors to our texture maps. So let's come back in here and we'll just swap those out. So we're going to come in here and say, great, this texture is our X, and so that's our red, so we'll replace our red and we'll replace our Z. And now, and you can see there, you saw the change, and now for our Y, we're going to plug in the Y channel. And let's make all of these our UV color. And so there you go. So there is our UV color, and as of right now, this looks very similar. So let's go to our camera 2, right? So this is our setup, and I'm going to go ahead and just for visual comparison, I'm going to make another scene viewer right here, and we'll make this camera 2, and then I'm just going to pin this, and then I'm going to go back to our stage, and then in our stage, we're going to go over to camera 2, and now we're going to have really, a render versus an OpenGL. But what we expect is we expect these to look the same. So if we start looking at this, we're like, yeah, it's totally the same, right? We've got a purple and a blue and a white, and like, yeah, it's the same. But then when we start really looking at it, this is a 4, this is a 3, right? So we're not quite the same yet. We're off. Why are we off? What is different about these two setups? Basically the thing that I discovered in this was just came down to some trial and error. So what I did was I came into my object, and let's pin this so this stays, and we're going to go to our object, we'll go into our height field and back into our little attribute VOP here, and I want to be able to move this map around. So there's a UV position. This is the one that I was looking for. And I'm going to hit P here in the viewport, and it's going to bring up my parameters. So I'm just going to plop this in and copy and paste this on each of one of these guys. And what this gives us the ability to do is scale and translate and transform. So, I tried transforming this or scaling this, and that wasn't right, because you look and the squares are about the same. But let's look at, what if we just move this? and we take a look. So if a lot of times the pivot is different on some of these different processes. So when I'm dealing with UVs and it's 0 to 1, I tend to say, okay, well, what's the next kind of midway point, or the next typical point that things are working around? It's either 0 is going to be the center, or 0.5 in texture case. So you notice that if we do this at 0.5 and 0.5, we now get a 2 and a 2 and a 1, and this now suddenly all lines up. So this is really the process for building out this displacement that we would need. So in order to do this now, the next step would be to replace these colors. So let's go there. Let's go to the next step. So right now this is with a singular map that we're using, right? And so we're going to take this and we're going to say, let's give our parameters here. I'm going to shrink this, give us a little more real estate to work with. Probably be better to split this in the middle. All right, so we're going to drop this one. All right, so that's going to give me kind of both, and now I have some room to work with here. So we can compare these. So I'm just going to take this attribute VOP, and I'm going to copy and paste it over here. And so before, this was using our texture. This is essentially going to be doing the same thing. Now, to make this work, I need some attributes on those points. Namely, I need these UV attributes that I've created. So I'm going to use this same UV transfer node that I was using before. I'm just going to grab off of here, off of this stack right there. All right. And for this, I don't want just the normals. I want the normals, and I want all these UVs. So I'm going to say UV, UVY, and UVZ. And you can already see, just doing that, the colors now match up between those. So that's already a great sign. So really then the next step is replacing these textures with our displacement map, and instead of going into the color, we would use a displace along geometry, and this would become our amount. Okay. If we want to be real technical, we would come in here and we, just like we did before, we would do a vector to float on each of these. All right, let's start pulling these off. If you want to be as clean as possible. Because remember, this isn't about the color here. We don't care about the color. This is really just about the texture, right? So, and in this case, we would say mix, just a regular mix node instead of a color mix. Right? So we'd swap out these inputs. And then this goes into our actual amount here. Because again, this is looking for a float. And we probably could have just done a vector to float right here. It's up to you. There's not a right or a wrong here. So now with this, we need to go and get our position information. So we'll pull that forward, plug that into our displacement, and then our position comes out. And so now we have made essentially our same displacement. Now we need our fit range node that we were doing before. All right, so we'll put a fit range here, and we were taking from 0 to 1 and going to negative 0.5 to 0.5. This is all the same stuff that was in the shader. And then we really need a multiply node here, right, to then be able to, oh, sorry, we didn't do it there. We did it right here on the scale. So we could scale this up based on what our needs were. So this would essentially be a one map solution, right? So how do we do it when we have more than one map? Well, the way we do that, I'm going to go ahead to simplify here. I'm going to get rid of these color nodes. Right? Is we need to mimic what we're doing here for our other textures that we're using. So if we're using 2 displacement maps, right, then I'm going to come in and I'm going to select this set of textures. And I probably, unless I'm doing different texture scaling, which you may likely be doing, I'm going to grab this set here so that we have a new set of position data. And I'll just grab all this because this is going to become, my set. And I don't usually modify this, so I'll just use the one. But so I'll copy this and paste. Okay, so we're going to go back to this setup here. So let's go look at. Go to stage. We're going to go look at that shader. All right, so this is material 1, and what we have is we're mixing a specular roughness, a specular, and a base color, and then our displacement. We really care about our displacement, so let's look at how this is set up. So we see that we have 2 different triplanar nodes. So one is using this texture, one is using the other. We're doing an adjustment to one of those textures, just kind of play with it and push it around a little bit. Ideally, you're not having to do this. But if you do, you're going to make a ramp, and you'll do the same thing that this is doing. It's not very hard. So we'll do that. And we're bringing in the mask, and this is inverting that mask so we get the part out that we want. So let's do this. So we're gonna do a mix. We're gonna have these 2 textures, and we'll do the ramp and the remap. So I'm just gonna copy. Oops, I pasted. That is not what I want. Control Z. So I'm gonna copy this. Go back to my object. Go into my height field. Go into my build here. And I'm gonna keep it on top and on bottom the way I had it. Okay, so if we want to make this a little easier to view, we could collapse these into subnets and make a little tool out of them if we want, but I'm not going to do that. Not today. So I'm going to paste this. There's that texture. I'll put it in all of these. I'm going to jump back over. All right, so I'm going to come into my material X. This is my other one. Copy, jump back. That's these ones here. I'm going to paste those. And now both of these are going to go into a mix node. And these were being mixed by the mask attribute. So I'm going to use a bind node and bring that in. And this is going to be the mask attribute. That's what we're using. Now, I could test this the way it is, but I already know that based on how I set up my shader, that this mask needs to be inverted to get the right ratio. So I'm going to put a fit range node on this, because that's what we had in that other one essentially. It was called a remap. We'll put the fit range node down, and this one is we're just going to reverse that. And so this is going to take 1 to make it 0 and 0 make it 1. All right, we're going to go one more time back to take a look in our material X. And the last thing is this ramp that is on our triplanar projection here. And I'm just going to right click and say copy parameter. You could even link these if you wanted. We're not going to for right now. And I'm going to come back to my attribute VOP. And on this guy here, there's going to be a ramp parameter. And we'll just call this, you always have to name these because you can't have 2 with the name being the same thing, because these are creating attributes or parameter interfaces. So we'll call this this map, whatever you want, adjust 1. Or maybe this is, yeah, sure. That works. It's going to be a spline, not a color. And then when I jump up, there it is. I can right click on this. I can say paste value, or I can say paste relative reference. If I do relative reference, if I make any changes in the shader, it's going to make the update here. That's very convenient. And so that can be very helpful. Okay, so now we've got that. I can do the same thing again where I jump out And for my overall scale that I'm doing here, I could right click on this and say copy to parameter. We could go back to our attribute VOP, and if you remember, we're driving that here in the displacement, right? That scale. So I can right click here and say paste relative reference. And now I'm going to plug this in to my fit range here. I know we got noodles kind of going all over the place, so I'm going to cut this. I don't care about the color. This now, in theory, is matching what our setup was. The one part that we might not have is our scale. Although if you remember when we did this, we saw the lineup between the texture and these, and that's the same setup. So let's just to double check that, we'll come in here and we'll look at what we're, for our triplanar projection here, we're at 0, 0, 1. And if you remember, we're at 0, 0, 1 also there. So we know that we're looking at this map at 0, 0, 1 for that triplanar position. Our setup was giving us the same thing when we were doing our visual check against that at the object level, right? When we came in here and we took a look at this, we were getting that same lineup, right? So when we came in here, you know, based off of these general positions here. So our UV textures are lining up at that 0, 0, 1 scale. Now, if we did something different than 0, 0, 1, then we would need to come in here and we would need to adjust our scale, but we haven't, so. Okay. So now if we go in and take a look, let's come back here. We're going to come back to camera 1. We're going to come back to our stage down here to make this easier. And let's turn on material 1, or just our main material here. We'll let that render for a second. Oh, one thing I forgot while this is rendering, we need to now reconnect these points with this new setup, right? This is the one that has our displacement, right? So we should call this attribute VOP point displacement. These are just the color-based ones, whatever we were doing before. We technically don't need these. We can just clean up our scene a little bit so we're not confusing ourselves. But now our points have our proper displacement on them, which is great. So we're going to view our geo there. And let's go back to our stage. And let's go ahead and plug in our instances. All right. So we're going to debug this because my setup is giving me not what I'd expect. If we look at where we were at to where we are now, our trees have actually gone the wrong direction. So that tells me that my mix on this might be inverted somewhere. So the first thing that I'm going to do is I'm just going to turn back that inversion of our mask attribute. Oh, you know what? I wonder if our points have that. I bet it does. I'm pretty sure it does. Let's go back to our height field. And if we look at our points, we should have a mask attribute, which we do. So if we were to visualize that, right, if we click there, we should see that in the viewport. We might not be seeing that because this is pinned. Let's try just unpinning this. I've got something messed up in my viewport that's making it so it's not showing me attributes. If I go to the geometry spreadsheet, I would expect that I see these attributes, and I do. So if I come across here, there is a mask attribute. It is populated, so I'm a little less worried about the viewport not drawing that as it is of what's happening to my points. Because we can see, if I look here and I view here, right, that my points are indeed moving. This point went down. So let's come in here and for this mix, let's just try in disabling that. Well, that already looks really much more promising. So if we just disable, yeah. So I think that's it. It's not perfect. You can see we have a little bit of a gap between the bottoms of our trees there, but you can see that now all the trees are planted on the ground where they should be. So We have some trees going down, some trees going up, mostly going up, and now everything is falling. So again, the reason we did this node was because this is what we were doing inside of our shader. What this tells me is that I just actually have this inverted, the setup. What matters is not that this is all exact. So the other thing I could do if I wanted to keep this exact is I would just reverse these inputs there, and now this will give me that same result. At least it should. Did I just do the same thing? I did just do the exact same thing. That's funny. There we go. So now that those are reversed, this now matches exactly to the setup as it is in the shader. So if I went into the shader and I increased my displacement, it's going to increase the displacement on these points so that they move. But point being that this now all follows. Where this gets tricky is when you have 5, 6, 7 different texture map sets plugged in, and this starts to get hard to manage, but that's a part of it. So the more complex our scenes, the more there is to manage. So it's important to always build very clean, be able to understand what it is you're doing, why you're doing it, keep track of how your files are set up, so your node structures are built. Okay. All right, let's go through one more, let's look at one more example here where maybe we're changing the scale, the repetition of our texture. And we're not going to go for something that looks amazing here, we're just going to show the principle. So don't judge it by the look of the outcome, judge it by the steps that we need to take in order to get the result that we're looking for. Okay, so I'm going to go back out to my object level here. I just kind of copied this in. We've got a simple setup here. Here's our points. Here's our surface, here's our normal. So I'm going to grab some of our setup here from height field 1. Let's take just a look at this real quick. Let's grab both of these just to make it easy. And really what I wanted out of this was to be able to take a look at and see, if we come inside here, the difference when we plug in our, because I expect that we're getting a little bit more of our other geo, and we can kind of accentuate this a little bit. So let's do this. Let's put in a couple of switches. That way we can quickly jump between our texture. Right? Oh no, I don't want you to do that. I want you to do this. So you're going to be our not that one. Thank you. You're going to be that one. And we'll put a switch here. Connect you there. And you are going over here. Here's that one. And one last switch. All right, if you remember, this was our red, green, and blue representing our X, Y, and our Z. So now with this, we can just come in and grab these and just switch to 1, and we should see that difference. So I'm going to go ahead and just push this around a little bit to help visualize. Right, if we take this height pattern, that size is fine. But let's just do this. We'll pull this across, pull this across. So we can see there now that we have lost that Z, or also gotten really, I think we've lost all our color, so there's something wrong in that setup. Let's check it out. And that should be our Z direction. That's blue. That's fascinating. I would have expected not to look like that. So if we switch this all back, do we see texture? And we don't. So if we plug in just our Z texture here, I'm checking the UV maps and saying, okay, do we have proper UVs, which we do. That's all black there, no matter what. If we come out, there's a possibility that. So this looks to be that our normals are giving us. So what this is this is I'm guessing a point normal versus a vertex normal issue. No, it's not that. So is it just our lighting that's doing that? It's just our lighting. Ah, there you go. See, it works. Yay! See, we all get tripped up every now and again. There's our blue. Here's our green. That's what we'd expect. So that's great. This is going to give us kind of that difference, and we'll see the benefit of the triplanar projection here. So I'm going to come back out to our shader now, and let's focus on that for a second, because the shader is what's really going to drive our point displacement that we need to do. So we're going to come into here. This is giving me something that's angry about ground height. Sorry, I need to be able to see. Let's do this. Okay, so I kind of have to go back and refresh in my mind where we were at as I was, plowing through this. Had the very sad and unexpected experience of a neighbor's pet who was in our care passing away from old age. So if there is a moment here where you feel like this is a totally separate tutorial or thought process, I apologize, because it somewhat is. There was a little family emergency break there in the middle. Okay, so I believe what I was trying to do here is do a setup where we use something that maybe the tiling wasn't as straightforward, and let's work through that to make sure that system works as well. So, we've broken off here and we've got a little bit different of a height field and a bit different of a scatter. So let's go through and quickly look dev this and get something on here that feels interesting to us to make sure that this looks good. So we're going to come in here and height field geo2, great. That's all coming in. This wants to be on ground 1. So this will put our shader on there. We can see over here from the kind of the GL of this, of what that's going to look like. But we're going to start kind of from scratch, because this shader doesn't really give us the tiling that we were talking about. We can use the same textures, that's fine. But I'm just going to quickly throw on some different textures that I think are going to do a better job. So of kind of giving us something that we can see the how that's going to work out. So. Okay, so we're going to just jump in here, and I'll just pause here as I set this up, because the texture map doesn't really matter here. It's going to be the process after, so stand by. All right, so here I just changed the shaders, not the shaders, sorry, the texture maps that I was using to a different set that had a little bit more, kind of rock appearance. And so if we look at the default of what we had before, which was this, which really gave us a kind of a one-to-one, like the texture map is mapped across the textures at a one-to-one level, and we can see that if we go out here. We're going to go to our camera 4 and look at it this way. Actually, let's do it here on the XView. We're going to go to camera 4. We'll jump back out, and instead of using material, we're going to use material 1. I think was the one that we had set up. Nope, not material 1. Sorry, material 2. There we go, material 2, and we'll just go ahead and we're going to get rid of the trees for now, because that's not what we care about. So coming back inside into material 2, we're going to do the same thing here, and we're going to make this 0.05, sorry, 0.005, and we can see that now we get a repetition of the tiles on our object, right? So then the question becomes, what does that translate to in our other setup? Because if you remember our other setup, we're using actual UVs. And so we need to go in and do the equivalent scaling in UV space versus in three-dimensional space. So let's go into our object level, and let's take a look at, I'll give that a second to catch up. Okay, so we're going to take a look in our height field number 2 here. We'll jump inside, and right now we have this all kind of teed up. If you remember, this is the setup that we had before. I barely can remember because, like I said, I had to step away. I'm going to switch back to 0 to give me my texture map. One other thing, we're going to go back to stage, and we're going to quickly pin this because we want that easy comparison between the two. So we'll go back to object now, come into our height field. We'll see that this is going to come up here. We'll look through camera 3, 2. Camera 2, so now we can see there's obviously a very drastic difference between these two, and we want to get those to match up. So we'll come inside and take a look, and this was our setup here that's pulling in our texture maps. And again, we're just looking to get our UV textures to line up. So in this case, using our UV position node, let's start playing with our scale and see if we can get these to match. And if you'll notice, we've got a, where our seams are here as far as that repetition. So we went 5 times the repetition. So let's try just giving this a value of 5. Nope, wrong way. So let's divide 1 by 5. So 1 divided by 5, no, not that, 1 divided by 5 gives me 0.02. I should have been able to do that math in my head, but it doesn't always work. So just looking at this, that already translates across. So now I can see that this is going to work just fine. So knowing this gives us a good visual check to jump back and forth and make sure our setups are right. Now, if I had 2 different setups, right? So if I came in here and one texture was at one setting and another was at another setting, let's look at that. So if I was to come in here and say, on this material here, right now, both of these. Oh, am I looking in the wrong library? No, that's the right library. Material 1. Sorry, I thought I'd done these a little differently. Oh, in here we're doing this, right? We have this at 0.005. So let's come back out. Oh, I'm jumping all around on you. I'm so sorry. So in our material 1 here, we're going to use one of these materials. We're going to leave at 0.001, and the other we're going to change to 0.05. Okay. So if we look at this now, if we were to assign our first material back to this again and then let this run, we can see here's the setup of that. We're using, as far as attributes go, we're still using mask, I believe. So let's go make sure we have a good mask on our actual geo here for the setup. So let's take a look at what our mask looks like. So we do have a mask. Oh, you're not showing me. So we'll come down here to this. We're going to right click and we're going to click the mask button here. And we can see in looking at this, it's not doing anything. So let's just give it a value, right? So, which makes sense. We haven't really done anything. So let's do a height by feature, mask by feature. And the default on this will be to use slope, and I'm just going to make this linear, and that's good enough for me because we just really want a mask to be able to see what this is doing. So there we go. I can come back in here, turn this on and off like so. And we could, in theory, set this up to do the same thing, right? So we could test this, and it's probably wise to do so. So we'll just slide this over, and we're going to need all of that set up. So let me actually do this. I'm going to come down here. I don't think I'm going to duplicate this. I'm just going to duplicate this part here. So copy and paste. And then we're going to do a color mix. And now this color mix needs our mask attribute as its bias. So there we go. We'll plug that into the bias. And now we have that set. So right now these are both doing the same thing. So we'll just take one of these and we'll put it back at 1 because we left one of ours at 0.01 and we put the second at what did I change here? I changed the wrong thing, didn't I? I did. That stays at 0.5, and this goes back to 1. Sorry about that. And so now what we should see, based on our mask, that didn't change anything. This is, oh, okay, so that's the one that it should have modified. UV position, scale. Oh, we are probably seeing a slight overlay of one over the other still, for the difference between these two. Let's see what this is. Let's invert these connections here. Hold on. On quick investigation, for whatever reason, when I highlighted all of this, it didn't change all of them. So now it did. So that gave us what we would expect there. The reason it looks like this, so if we were to change this back to 0.2 and 0.2, we see there's the change. 0.1, oh sorry, 1 and 1. And so that's larger. What we're seeing here is that kind of that overlap of the triplanar projection. We're getting a couple different UV maps being mapped onto itself here. So, which isn't great, but this is still showing us this kind of general example here of the setup. And so we now can go in and we can check this against our regular shader. I'm going to switch this back so my primary is on top and my secondary is on bottom. That way it just kind of is cleaner and we're not crossing lines. So there we see that's what we get. So I want this to match with the same idea on this side here. So if we come back, we'll leave that at XBU. We're going to come back into our stage now. We're going to go into the material library, and it's this library 2. Oh, sorry, material 2. Which one are you? It's this one here. So we're gonna make an adjustment to this where we essentially want to do the same thing with this. So we're gonna do a color mix node. It's just called mix, maybe. It is just called mix. We'll plug in this one into our foreground. We'll plug this into our base color, and then I'm just going to copy and paste this for my second input. And then we need to bring in a geometry property value. In this case, it's going to be mask. We'll bring the mask in. We'll plug this in, and let's go back to the stage. Point that at material 2. This should be our rat. There we go. And we'll jump down inside here again and just make sure that we have changed. This one here is going to stay because at the top we kept it unmodified. We kept the scale at 1, which would be the equivalent of 0.001 in this multiplying of the geometry. So that's what we should expect from those two. We should be able to tumble around this and see there is a difference there. Now you'll notice that I think this is going to end up being the inverse of what we intended. So it just means that one of our setups is out of sync as to which one we did. Let's go back and take a look. So we're going to go to our object. All right, you can see there that this is the opposite of that. And so top, bottom, bias mask, this one is our, these are the kind of things that are a little frustrating because you would expect it to behave the same. So this, the one that's on the bottom, should be our 0.005, and this should be our this should be our 0.2, and this should be our scale of 1. Okay, so now we're going to go to the stage. Pardon me for my mental hiccup. I'm getting old. So our top one, yep, this is what it should be, and it's giving us the inverse. So this is why I do these visual checks, because now really it's just a matter of inverting this mask and saying, okay, great, I can either remap that or I can just reverse these inputs to look like so. Oops, not like that. Come on, there you go. And this will come down here like this. So that's giving me what I would expect. This now matches. So if this is my setup, and again, it's just a matter of keeping things matched. So if you've built the shader, right, then really this is probably the wrong way to have done it. If this is representative of my shader, then the way to fix this is I ought to go to the object level and fix my attribute VOP. Because if you remember, this is what we're going to be using to manipulate our points to our shader. So we really want to change this here, right? Because our shading doesn't care about this. So in this case, I'm just going to reverse these inputs. And now this should be giving me the same as this. And again, I'll point out that this looks like this because of how it's interpolating, but this is the expected results. So with this setup, I can now copy this attribute VOP over to my points and do the same thing that we did before, which is I will go in now and, so if we look at this previous one, I will put this on a displacement node. I'll use the fit to change my min and my max. I'll match my scale to the displacement of my shader. And then these textures will then take on the textures that we're using for displacement. So now we're at the point that everything transitions back to what we were doing before. We have differences of shaders or of scales that we're wanting to use. So this should get you that rest of the way. This is probably one of the hardest parts about scattering, is just managing all of this information, doing it as cleanly as possible, naming your nodes. I like to use linking as much as I can so I'm not changing it in multiple places. So as I set things, for example, I would come in and I would link my texture map from my shader to this texture node, so that way it's pulling in the right map no matter what. Those kind of things are really helpful. So, okay, as a recap, we went over how to transfer our displacement from our shader onto our points that are having geometry instanced to them, so that way our geometry moves with our displaced surface. There are certainly other ways to do this. This is one way. This is the way that I kind of have always done it. So, if you have thoughts or suggestions, clickety-clack and put them down in the bottom there and share your thoughts. I hope this was helpful to you. If you have any questions, please don't hesitate to leave them in the comments. If you've watched all the way to this point, thanks for hanging out with us till the very end, and subscribe and like if you found it helpful. Thanks for watching.